question 4, we're given a diagram that has two functions, the function f, which is an exponential function, and the function g, which is a hyperbola. We're told that they intersect at point A and point B, and that the hyperbola has the centered coordinates of -1 and 3. The first question is asking us to find the coordinates of A. We're going to use the function of g. The values. For the coordinates of A, we are going to use the values of the f of x. We're going to use the f of x 1 to the 5 to the power x. We know that here x is equal to 0. So 1 to the 5 is equal to 0. The coordinates of A are going to be 0 and 1. The second equation is asking us to determine the complete equation of the gx by finding a, p, and q. We're already given the values of p and q from the function. These are the coordinates of the asymptote, where x is -1. The x can be written here in p plus 1, and then q becomes the y value plus 3. We already have our p and our q. One way to get our a is by using the coordinates of a. So we have our y, that's going to be 1, a is going to be 0 plus 1 plus 3. Take 3 to the other side, 1 minus 3 is going to be 3. A over 1 is a. Therefore, we have our a is -2. Now, we're told we need to find the inverse function of f of x. We know that f of x is equal to 1 over 5 to the power x. The first step when you're trying to find the inverse of a function is by swapping y and x. So this is going to be x, this is going to be y. And then from this point, we want to make y the subject of the formula, where y is equal to log 1 over 5 and x. This is the equation of our inverse function of f of x. Now, the next question is asking us to draw the inverse function of f of x. Because we know that our f of x was 1 over 5 to the power x, and our inverse was log of 1 over 5 and x. An important thing that we need to know is that f of x, inverse of f of x, is the reflection of f of x across the y is equal to x line. So this imaginary line y is equal to x, and the inverse of our f of x is a reflection of that, is a reflection across this line. So it's going to be a reflection this function. This is the inverse of our f of x function. We also need 2 points, so you can get that this is 0, 1 over 5 is x, so one of the coordinates that we have is 1, 0. Another point, another point we can put in a calculator, where important thing to also realize about inverse functions is that in the original function, you have your y values and your x values. In the inverse function, your original y values are going to be your x values. So in the f of x function, you have the y values and x values. And the inverse, your x values are now going to be your y values, whereas your y values are going to be your x values. For example, the coordinates of A. In the original function, the coordinates of A were 0 and 1, where x was 0, but y was 1. In this new inverse function, the coordinates that we found here were 1 and 0. 1 and 0, where the new x is 1, new y is 0. This just a reflection. So this point is a reflection of A about the x is equal to x line. Next question is asking us to find values of x that will allow the inverse function of x to be greater or equal to -2. We can substitute our equation that we got, log 1/5. We do know that from our log functions, if we have y is equal to a to the power x, making x the subject of the formula, we use log a to the power a and y. Currently, we're at this point, we're here. We want to move to this side. So what we're going to do is say, take the base 1/5 to the power -2 greater or equal to x. This 1/2 to the power -2 is going to be 25. So we found that values of x that will allow the inverse function to be greater or equal to -2 are values that are less than or equal to 25. The final question on this section is asking us to draw a new function, h of x, which is simply a transformation of g of x. When we transform or shift the hyperbola, the easiest way to go about it is to shift the asymptote. So the information that we have is that we need to move the gx function 1 unit to the right and 2 units downwards. So we look at the vertical asymptote first. Currently sitting at -1, we need to move the vertical asymptote 1 unit to the right. So it moves from -1 to the y-axis. So the new vertical asymptote will be sitting along the y-axis. Whereas the horizontal asymptote is currently sitting at -3, it will move 2 units down until it goes to position 1, positive 1. So our new horizontal asymptote will be a positive 1. So our new function will be here. A new function will be here. The g of x equation we found it to be -2x plus 1 plus 3. The new h of x equation, h of x is going -2 remains as it is. -2 remains. X. The only things that change are p and q, the coordinates of the asymptote. Initially we had x plus 1. Now, because our vertical asymptote is sitting along the x-axis, we're not going to have anything here. So it's just going to be negative 2 over x plus, because our new horizontal asymptote sits at positive 1, it's going to be 1. So our new equation is going to be negative 2 over x plus 1.